Next, according to type of accessing allowed. So based on this one here, the memories are divided into two categories, that is read-only memory and read-write memory. So here in this read-only memory, we have different types of memories are available. Those are read-only memory, programmable read-only memory, erasable programmable read-only memory. That is, we will call that as EEPROM. And next one is that electrically erasable programmable read-only memory. That is EEPROM. And last one is that flash ROM. So these memories we can read only, but we cannot write. So this is about that read-only memory. And next we have read-write memory is there. So in the read-write memory, we can write and we can read. That is, we can write the data into the memory, and at the same time we can read the data from that memory. So the example for this read-write memory is that main memory, magnetic disks, and magnetic tapes. So these memories which are allowed to read and write operations. So this is about according to type of accessing allowed. The next one is according to the active devices used in that memories. That is, it may be either read-only memory or it may be either random access memory. So based on this one, the memories are classified as bipolar memories, and another one is that mass memories. So coming to these bipolar memories. So in these bipolar memories, for the construction of this memory, they will use transistors. So these transistors acts like a memory cells which are used to store either binary value 1 or 0. And coming to these mass memories, here they will use to store the data by using that mass transistors. That is nothing but metal oxide semiconductor field effect transistors. So these are acts like a memory elements, and these memory elements which stores either 1 or 0. So like this, these memories are classified based on the transistor which is used in these memories. So mass transistors, they have lesser speed compared with the bipolar memories, but these mass memories are very cheaper. So this is about the classification of memories according to the active devices used. And next, according to the period of storage, the memories are classified as volatile memory and non-volatile memory. So coming to this volatile memory, so when the power is gone, then the entire data which is stored in that memory is lost. And coming to this non-volatile memory, here whether there is a power supply or not, the memory can store the data permanently. So this is about that volatile memory and non-volatile memory. Next one is according to the state of data transfer. So based on this one, the memories are classified as destructive memory and non-destructive memory. So coming to this destructive memory, so after reading the data from the memory, the data will be lost. That is nothing but we will call destructive memory. Coming to this non-destructive memory, so after reading the data will not be lost. That is, after read operation also, the data will be reside within the memory. But when you are going for the destructive memory, after the read operation, the contents of the memory will be erased. That is, the memory is lost. So this is about that classification of memory based on the state of data transfer. And next one, according to the moment of data, the memories are classified into static memory and dynamic memory. So coming to this static memory, the location of the data is constant and it will not be changed. So to change the location of the data within the memory, then you have to use that move instruction. Then only the data location will be changed. That is nothing but the address of the data will be changed if you are using move instruction. And coming to this dynamic memory, in this memory, the position of the data will not be constant. That is, it will be changed randomly, we can say that. So the construction of the memory itself will be such that the data has to be moved from location to location. That is here without using of move instruction, the data location will be changed. So this is about the dynamic memory. Now we will discuss about that read-only memory. Shortly we can call it as a ROM. So here I am showing one figure. So this figure representing that diode ROM or ROM using diode. Here these rows are representing that address lines and these columns are representing that data lines. So here within this figure, here we have a diode and here and here and here. So when the diode is present, that is nothing but logic 1, and when there is no diode, then that is nothing but logic 0. So like that, the data will be stored in this ROM using diodes. So here we have logic 1, this is 1, 0, 1, 1, and next here we have 0, 1, 1, 0, and next here we have 1, 0, 0 and 1. So like that, this ROM stores the data. So when there is a diode, nothing but logic 1. When there is no diode, then it will be logic 0. So like that, this ROM using diode stores the data. And next, ROM using decoder. Here we are using a 3 to 8 decoder. That is, by using 3 selection lines, we can select 8 outputs. That is, for example, A0, A1 and A2. These are the selection lines. And by using these selection lines or address lines, we can select either one of the output pin. So here, for example, A0, A1, A2 is 0, 0, 0, then the pin 0 will be selected. That is nothing but address line. That is address line 0 will be selected. And if it is 1, 0, 0, then pin 1 will be selected here. If it is 1, 1, 1, then the 7th pin will be selected. So like that, here we have 8 outputs will be there from 0 to 7. Okay, so now we will connect these pins as address lines for the ROM, and these columns are data lines. So again the same thing what we discussed in that ROM using diodes. So here when the diode is present, it will be logic 1. When there is no diode, it will be logic 0. So like that, we will use this ROM using decoder. And the address and data of typical memory, that is serial number, that is for example, if the address is here 0, 0, 0, that is A0, A1, A2 or 0, 0, 0, for this address line here, pin 0 will be selected. Here pin 0 will be selected. So the logic here it is 1, 0, 1, 1. So see here, it will be 1, 0, 1, 1. And if it is 7, that is, if it is 1, 1, 1, that is A0, A1, A2, then we have the logic, that is the data which is resides within the memory, that is 1, 1, 0, 1. So 1, 1, 0, 1. So like that, here the data will be stored within the memory. This is about that ROM using decoder and ROM using diode. Next one, types of read-only memories. In this, the first one is that programmable read-only memory. When you're going for that read-only memory, here it will be so expensive and there will be a wastage of time, because you have to place that each diode when it is logic 1 and you have to remove that diode when it is logic 0. So instead of doing like that one, here there is a programmable read-only memory is introduced. Okay, so here I will show that the figure of that programmable read-only memory before programming. So here the same thing, 3 to 8 decoder we are using, and this A0, A1, A2 are the selection lines which are used to select that particular output pin 0 to 7. And here if you see this one, from 0 to 7, these are the address lines, and here these are the data lines. If you see here, the diode is connected through a fuse. So if the fuse is burned, then there is no diode. If the fuse is not burned, then there will be a diode. So if a diode is present, it will be a logic 1. If the diode is not present, then it will be a logic 0. So like that, here by programming, the fuses will be burned so that there will be a diode and there will be not a diode. So like that, we can store the data. So this is about that programmable read-only memory. And if you see here, the fuses are burned here, all the fuses are burned here. Okay, so this is doing by using the programming. So here I am not explaining about the programming, how it will be done. So in future we will discuss about that, the programmable read-only memory. Erasable programmable read-only memory, simply we can call it as a EEPROM. So here if there is any modification, that is, if there is any alternation is required in that read-only memory, that is nothing but programmable read-only memory, then it cannot be possible. But it can be possible in this erasable programmable read-only memory. Simply, we can call it as a EEPROM. So here in this EEPROM we have two types will be there. One is ultraviolet EEPROM and second one is that electrically erasable programmable read-only memory. So UV EEPROM and next one is that electrically erasable programmable read-only memory. Here in this UV EEPROM, simply if you are exposing this chip under the UV light, then the data will be erased and you can again rewrite into that UV EEPROM. And coming to this EEPROM, then we can erase the data within this memory simply by using some electronic equipment. So by using this electronic equipment, we can erase the data in this EEPROM, and at the same time we can write the data also in this EEPROM. So this is about that UV EEPROM and EEPROM. And coming to this comparison, so in this electrically erasable, these devices can be erased and programmed with electrical signal, where in the UV EEPROM then it can be exposed under ultraviolet light to erase the data. And here in this EEPROM, the voltage on floating gate structure permits that storage, and here the photocurrent from the insulated gate structure permits that storage. So this is the difference here between EEPROM and UV EEPROM. And next one is that speed of operation is more in EEPROM compared with that UV EEPROM. Easy to construct and economical, but when you're going for that UV EEPROM, it is very difficult to construct and expensive. So this is about that UV EEPROM and EEPROM.